Hi all, in the last class we were discussing problems related to pseudo inverse using SVD. So in this class also we'll just continue. I will just do two to three problems. So let's move on to the problem. So let's find the pseudo inverse of a 2 by 2 matrix. So we are given with 1, 2, 2, 4. And what do we need to find? We need to get U, V and sigma plus to get A plus. And also we need to verify that A plus A is equal to A. Okay, that will do. And now coming to what we do, we find A transpose A, and your A transpose A is here. And what we next do, we find the eigenvalue. So your eigenvalues is 25 and 0. See, 1 is 0. So what is your corresponding sigma 1 will be equal to root of 25, that is 5, and your sigma 2 is equal to 0. Okay, how many non-zero singular values are there? It's just 1. So your rank of this particular matrix will be equal to 1. And yeah, since you have rank of A is equal to 1, and now what we do is we'll just find the eigenvector. So to get the eigenvector, what we do is we'll just get the matrix minus lambda I into V is equal to 0. So correspondingly we have V1 is equal to 1, 2. Now we need to normalize it. For that we do root of 1 square plus 2 square, which is equal to root 5. We have it here, and then just divide each entries by root 5. So this is your orthonormal eigenvector. And now also you have lambda 2 is equal to 0. Just also get the eigenvalue for eigenvector for lambda 2 also. So you have your eigenvector is equal to minus 2 and 1, and then just normalize it by dividing by root of 2 square plus 1 square, which is by root 5. Okay, and after getting v1 and v2, what you can do, you can form just v. So v will be, yeah, first entry will be, in fact you will be having your first entry will be 1 by root 5, 2 by root 5, it will be minus 2 by root 5 and 1 by root 5. You can just take the root 5 outside to get v. Okay, that's how we have this v. And now we need to get u1. So what was ui equal to? Ui was equal to 1 by sigma I into a into vi. So your since first the eigenvalue was equal to 1, you can just have your u1. For u1 you will be having a into v1, so it will be 1 by 1 into a into v1, and get your u1. Okay, now there is an issue for u2. What happens to u2? Your lambda 2 is equal to 0. Since lambda 2 is equal to 0, we can't use the equation 1 by sigma, which will imply sigma 2 is equal to 0. So we can't use sigma 2 into a into v2. Since 1 by 0 is equal to infinity, we can't use this. So what we do is we'll just take a sigma 2, we'll just form a u2 which is orthogonal to u1. Okay, our u1 was equal to 1 by root 5 and 1, 2, right? This was your u1. Okay, now to get the your u1 is equal to 1 by root 5, 1 by 2, and that is equal to 1 by root 5 and 2 by root 5. And to get the new vector which is orthogonal to u1, so there are many procedures to do that, but you can just identify it in a like trial and error manner. Suppose your u2 is xy, how can you get the orthogonal u2 is by multiplying u1 dot u2, that is you'll have to get 1 by root 5 into the first entry of u2, that is x, plus 2 by root 5, which is the second entry of u1, into second entry of u2, should be equal to 0. Okay, so by seeing itself we can just verify if x is equal to 2 and y is equal to minus 1. What happens here? It will be 2 by root 5 minus 2 by root 5, it will be equal to 0. Is it? So choose your x to be 2 and choose your y to be negative 1. Okay, so now also you can just do, what you can do is you can just normalize your u2. So for that this is your new orthogonal vector, and to normalize it you can just divide it by root of 2 square plus minus 1 the whole square, which is equal to root 5. So your u2 will be equal to 1 by root 5 to negative 1. Okay, so here it's minus 2 and 1. So what happens here is here we choose, I'm sorry for that, here we choose x equal to minus 2 and your y is equal to 1. Then also your, what happens by multiplying, it will be minus 2 and this will be plus 2. Is it? and that is also equal to 0. You can choose it randomly. Since I have just typed it in this way, we'll just follow the pattern. So just take us u2 is equal to 1 by root 5 minus 2 and 1. That is an orthogonal vector. So whenever you want to have a orthogonal vector, just imagine if it's 1 2, what you do is just interchange them and take the negative of 1. Okay, if it's 2 by 2, and if it's 3 by 3, we'll see how to get it. So it was 1 2, so what we did is we exchanged it to 2 1 and took the negative of 1. Okay, any one is fine. Now you have u2 and then just form u. So your u will be, and just write it in the column. This is your u1, this is your u2, and you have 1 by root 5 outside. And your sigma, you have the first eigenvalue to be, it was 25, so you can choose to be 5. Root of that is 5, and you have 0, and your a was 2 by 2, so your sigma will also be 2 by 2. And now what will be your sigma plus? You'll just take the inverse of 1 by 5, and you have 0, so let it be 0 itself. And so your rank of a was 1, right? So you will just take only the first eigenvalue, and then the remaining will be 0. So here your sigma 5 will sigma plus will also be having the same order, and this will be 1 by 5. Okay, now what was your a plus? It was v sigma plus u transpose. Okay, so just do how will you get yeah, you can just verify that by multiplying. You will have to do that. Okay, just type your v here, and just give your sigma plus, which is 1 by 5 0 0 0, and just get your u transpose. What is your u transpose? That will be 1 2 minus 2 1 into 1 by root 5, 1 by root 5, right? Taking the transpose of this u, and write u here, and then get the multiplication. Okay, and then you will have to find what is a plus equal to. Okay, I just okay, you will have to find what is a plus. And in the question, it also asked you to verify that a plus a is equal to a, right? A pseudo inverse of a is equal to a. It was asked to verify that. So what you can do is just multiply. Okay, you are given with a, we have this will be our pseudo inverse. Okay, I just put I just forgot to mention a plus, which is a pseudo inverse. You will have to find it, and then this will be your a plus, and just multiply a plus, and then again that into a. As you can see here, you will be getting that is equal to a, which was your a given in the question. Okay, so you can verify this also. Now we'll just see another question to find the pseudo inverse of a, and the a is given as 1 1 1 1 1 1. And also you are asked to find the minimum norm solution of ax equal to b, where b is given by 2 2 2. We'll see. So what we basically do in this problem is we'll just find the pseudo inverse of a, and then we are asked to find the solution of ax equal to b, and taking a to the left, this will imply by multiplying the pseudo inverse. So this will be basically be like this, and since this is the pseudo inverse, this will get cancelled, and this will give you x. Value of x is given by a plus b into x, and this particular x is given, and this x is known as the minimum norm solution of ax equal to b. So basically you'll have to find the pseudo inverse and then do pseudo inverse into b to get the solution. Now we'll just see. Okay, so to get pseudo inverse, we know what to do. We just calculate A transpose A. We have this one, and now we'll calculate the eigenvalues. So eigenvalues are 6 and 0, and using 6 and 0, we find the singular values. Root of 6 is root 6. Let it be like that, and root of 0 is 0. So we have only one non-singular value, and that's why we have its rank of A is equal to 1. Since rank of A is equal to 1, our A was a 3 by 2 matrix, so your sigma will be a 3 by 2 matrix. And how will you get the sigma? Your sigma will be, since it's 3 by 2, what happens here is we will write the first eigenvalue root 6, and you'll write 0 in the next. And sorry, you will have only one, since you have only one non-singular non-zero singular value, right? Just write root 6 here, and then we need a 3 by 2 matrix, so make it 3 by 2. Now it's 3 by 2. This is your sigma, and to get sigma plus, what you do, we'll just reverse it, right? And we will make it 2 by 3. So that will be of this form. Okay. Yeah. Now we have the eigenvalues lambda 1 is equal to 6. Let's find the eigenvector. So here you have your eigenvector, this A transpose A minus 6 V is equal to 0, and your V is equal to 1 1. Okay, your eigenvector will be 1 1. Then to normalize it, you will divide it with the square root of squares of sum of squares of the entries, and we have V1 is equal to 1 by root 2 1 1. And when lambda 2 is equal to 0, what happens? You need a vector. Yeah, we will find the corresponding eigenvector by doing, what will we do? A transpose A um, minus lambda I, but here lambda 0, so we'll have A transpose A into v, let me take to be xy is equal to 0 0, and you can just stick with and get the second eigenvector, and you have the second eigenvector to be v2 is equal to this one. I will just form v by writing it in the columns. This is your v1 and this is your v2. So you have v now, and now you have to calculate u. So for that you have to calculate what is u1, and we have our u1 was equal to 1 by sigma 1 a v1. And so let's see what is a v1 first. So a is given here, and your v1 is 1 by root 2 into 1 1, and on multiplying them you have 1 by root 2 2 2 2, and while taking this root 2 to inside you have root 2 root 2 root 2. Okay, this can also be, yeah, let it be root 2 root 2 root 2. And now you'll have to get u1, what you will have to do is divide them by sigma 1 1 by sigma 1. So your sigma 1 was root 6, so 1 by root 6 of this one. You can take this root 2 to outside. Okay, then this will be 1 1, and this root 2 by root 6, what happens to that? Here it will be root 2 by root 6 can be written as root 3 into root 2. So root 2 gets cancelled, and here comes 1 1 1. So it will basically be root 3 1 1 1. Now you have u1. We need, okay, now we need to find u2 and u3. Since your, as you can see, your A was a 3 by 2 matrix, it was equal to 1 1 1 1 1 1 1, is it? And so your u should be a 3 by 3 matrix. So but you have only u1, right? You have your u1 is equal to 1 by root 3 into 1 1 1. This was your u1, and you need to choose u2 and u3 arbitrarily such that they are orthogonal to u1. So let's see how can we choose that. And before that, yeah, coming to u1, how do we do that? So let me first choose u2, which is orthogonal to u1. Okay, let u2 be xyz, since we need a three member of R3, let it be xyz. And what happens is, when multiplying the first component of, that is 1 by root 3 plus, sorry, 1 by root 3 into x plus, again the second component of u1, which is 1 by root 3 into second component of u2, which is y, plus third component of u1 into third component of u2, which is z. Okay, this should be equal to 0, and we should choose the values of x y z to be arbitrary. Okay, what can we do? So let me choose my x to be 1, my y to be minus 1, and z to be 0. Then this satisfies, right? You can choose it arbitrarily, but the thing is, when multiplying them, it needs to be 0. So let's choose 1 minus 1 and 0, and let's that is our u2. So it's 1 minus 1 and 0. But the thing you need to know not is that our vectors should be orthonormal. We should normalize them. So what we do, we divide them with square root of 1 square plus minus 1 the whole square plus 0, which is equal to square root of 2. Okay, just divide square root u2 by square root of 2, and this is our required vector. And we also need a other vector u3, which is orthogonal to both of them. Okay, so how do we do that? So for that, let me write it again. Okay, so we need to get u3 such that u3 is orthogonal to u2 and also orthogonal to u1. So let me take, if it's orthogonal to u1, what happens? Let me take my u3 to be xyz now, and now I need to find this u3. Okay, so for that, let me see what happens to u1. and u3. Let me combine that. So let me multiply the corresponding entries. So first entry is multiplied will give you x by root 3, second entry is multiplied will give you y by root 3, and third entry is multiplied will give you z by root 3. This should be equal to 0. Okay, so this is from u1 and u3. And now let me take u2 and u3. Okay, so multiplying first entries of u2 and u3, what happens? That is x by root 2. Is it? Now the second entry is minus 1 by root 2 here, and it's y. So that would be minus y by root 2. And multiplying the third entry, it is 0, right? 0 into z. That should be equal to 0. So basically this is x by root 2 minus y by root 2 should be equal to 0. So uh, from here you can choose the values of x and y arbitrarily to be 1 and 1. Is it? But before that you should also make sure it is satisfied by this equation also. Okay, so let me choose x to be 1, y to be 1, and let me substitute it in my first equation. So what happens if this is 1 and this is 1? What happens? 1 plus 1 by root 3 plus 1 by root 3, this will constitute 2 by root 3. So in order to get 0, I should choose my z to be minus 2. Okay, then only 2 by root 3, then only we will have 2 by root 3 minus 2 by root 3 will be equal to 0. Okay, so it's fine. You can choose your x value to be, x will be equal to 1, y will be equal to 1, and so your z will be equal to minus 2. Okay, that is our new vector u3 here, and also you can normalize them. How will we normalize? Root of 1 square plus 1 square plus minus 2 the whole square, which is equal to root of 1 plus 1 plus 4, which is 6. Okay, just divide by 1 by root 6. So you have u3, we have u1, u2 and u3. So in order to get some vectors orthogonal, what you do is we'll just multiply the corresponding entries, okay, and then add them and equate them to 0. Then choose the values of x, y, z to be arbitrary, and if it is a component of R3, when choosing arbitrary you will have to satisfy both equations. Okay, the values of x, y, z should satisfy this first equation and also the second equation. Okay, then you have u1, u2, u3. Now you can form a u3 by 3 matrix. How you know this u should be a 3 by 3 matrix? Just by seeing the order of A, it was 3 by 2 matrix, so your u should be 3 by 3. Okay, your v should be 2 by 2. That's a condition. Okay, now you have your u, you can just write the corresponding entry. So it was 1 by root 3, 1 by root 3, 1 by 3. This is u1, and your u2 will be 1 by root 2 minus 1 by root 2, then 0. Your u, the last column will be 1 by root 6, 1 by root 6 minus 2 by root 6. So you have your u now. And now you have your sigma. First eigenvalue was root 6, sorry, first singular value was root 6, and only there was one singular value, so rank is 1. So you have only this entries, and you can make it 3 by 2. Your sigma will be 3 by 2, and just all other entries 0. And just for sigma plus, you just make it 2 by 3, and you have your sigma plus here. And now what you do to get a plus, you multiply, you have v, we have sigma plus now, and we have already found what is u2, u transpose, u just take the transpose of the matrix and then multiply them, multiply the three matrix, and you will have a plus, sorry, pseudo inverse of a is equal to 1 by 6 of 1 1 1 1 1. Okay, you can just verify this and get your answer. So I hope by this we'll conclude. And sorry, before that, it was asked to find the solution of ax equal to b, right? In order to solve x equal to b, so we were asked to find the minimum norm solution. So what we do is we'll just do x is equal to pseudo inverse of a into b. Okay, so we have pseudo inverse of a and we have your b, and what we do when multiply, you have this is equal to 1 by 6 into 6 by 6, which is 1 1, right? So your solution, this will be a minimum norm solution, which is 1 1. Okay, so your pseudo inverse is given by this particular matrix, and your minimum norm solution is given by 1 1. So this should be your conclusion, and I hope the question and the answer is clear. And coming to the next problem, so we are given with a question, we are given with a is equal to 1 0 1 1 1 2, and we are asked to find, show that a has full column rank. A full column rank in the sense we'll have to prove that this a is a 3 by 2 matrix, and we'll have to prove the rank of minimum rank possible for A is 2. Okay, for a random m by n matrix, if m is less than n, the maximum possibility of rank of A is m. Okay, the smallest value is the maximum possible rank, and since here A is 3 by 2, the maximum possible rank of A is 2. So we'll have to prove that A has full column rank, in the sense rank of A is equal to 2. Okay, we'll have to prove that in first. It's easy when we are finding the singular values, and we'll just see how what comes the rank, and then we'll find the pseudo inverse. And if the column rank is full, if the rank of A is equal to the number of columns, then what happens is, to get the pseudo inverse, you need not do the whole procedure. It is easy. You can just use this formula A transpose A. We have the matrix, and we'll just find the inverse of the matrix and get them multiplied by A transpose, and you get the pseudo inverse. Okay, this case is only possible if A has full rank, full column rank. Okay, you should remember that when the rank of A is strictly less than the value of m, if this rank of A was equal to 1, you are not allowed to use this formula. Okay, only you can use this formula, pseudo inverse is equal to A transpose A the whole inverse A transpose, in the case if A has full column rank. So let's see how the solution comes. Yeah, so you are given with your A, you have your A. We'll find what is A transpose A. So just multiply and get the answer. That is 3335. Okay, now we'll just find the eigenvalue of this matrix. And your eigenvalue, you'll have a quadratic equation, and on solving that, your lambda will be 4 plus or minus root 10. Okay, 4 plus root 10 and 4 minus root 10. And what happens? How many eigenvalues do you have? 2, and both of them are non-zero. So your rank of A will be equal to 2. Okay, since it is a non-zero singular values, but since you have no zero eigenvalues, your non-zero singular values will also be equal to 2, hence your rank of A is equal to 2. Okay, so we have rank of A is equal to 2, and that is equal to number of columns. This is equal to number of columns, and since this is equal to the number of columns, it has full rank. Okay, it has full column rank. So your first question is solved. Okay, now to get the pseudo inverse, you have the formula. Yeah, we'll just find the inverse of A transpose A, the inverse of A transpose A, and you have the matrix A transpose A already, and to get the inverse you need to get the determinant first. So what is the determinant of A transpose A? Before that, what was A transpose A? Let me see. Yeah, you have the A transpose A before, that was 3335, right? And to get the determinant, let me see, 3335. And to get the determinant, 3 into 5 minus 3 into 3, you have that is 6. Your determinant is 6. And to get the inverse, how do you get the inverse? You will just, since this is a 2 by 2 matrix, to get the inverse it's easy. You just like exchange these entries, that is the first entry and the last entry. You just exchange them. So your inverse will be 5 3, and then what happens, you just add a negative sign to both these entries, that is minus 3 minus 3, and then divide them by the determinant 1 by 6. In short, your inverse will be equal to 5 by 6 minus 3 by 6 minus 3 by 6 and then 3 by 6. This is your A transpose A inverse. Okay, you have A transpose A inverse, and you will just multiply them with A. Let's see what happens. Okay, now your pseudo inverse given by A transpose A the all inverse A transpose, and your this was your A transpose A the all inverse, and just multiply them with A transpose, and after multiplication you have your pseudo inverse to be 1 by 6 5 2 minus 1 minus 3 0 3. This is your pseudo inverse. Okay, so in order to get the pseudo inverse, if A has full column rank, that is very necessary condition. You should just make sure that you are given A has a column rank, has a full column rank, to use this formula. Okay, if it is having a full column rank, you can just see the pseudo inverse by A transpose A the whole inverse into A transpose. In case if this formula is not given in the question, you should learn that. Okay, if you are given with the full column rank matrix, what you should know this formula. A pseudo inverse is equal to A transpose A, the Hall inverse into A transpose. Okay, this is how you get the pseudo inverse. So I hope I'll conclude the session. Thank you.